Hey everybody, this is Mr. Shibley. As you can see, we're going to be talking about limits today. You probably already have your Chromebook as you're watching this video. Objective is students will be able to interpret the limit of functions when given a graph. So when given a graph, we can interpret the limits. By the way, it's my first time doing this, so we'll see how it goes. I hope it works out. But I want to make sure you get the learning in today, okay? So, you've already done this part. Pause and take notes when needed. So, if you're watching this video and you're like, what are you talking about? Pause it, take notes, right? Cool. Move to the next slide. Here's your calendar, okay? I wonder if it's even... yeah, it should be fine. Trying to make it even darker here. Here's your calendar. We had the summative. I think the beginning of part of tomorrow, you're going to have some time to finish your summative if you haven't finished your summative yet. Okay? Our summative for this one will be right before spring break on the 5th. Okay. Our essential question for today is, what is a limit in math? What is a limit in math? So by the end of the day, we will know what a limit in math is. I really hope it shows up well here, by the way. If it doesn't, then I'm wasting all my time shooting this video. So hopefully it does. Man, I need this one. I need polygons. Okay, you guys can probably still hear me as I'm on this way. Polygon. So, a three-sided polygon. That is a triangle, right? It's a three-sided polygon. We're going to talk about a limit, and you're going to see why I'm doing this, okay? A four-sided polygon, square or rectangle, right? Four sides. Think about what happens to the shape the more sides you get. Five-sided polygon. And there, pentagon. Okay. Think about what the shape is getting closer and closer to. And then an eight-sided polygon, like a stop sign, right? No, stop sign might be same. Eight-sided polygon. Look at the transition to the more the sides are, what is happening to the shape. If I made a 20-sided polygon, psych, that'd be way too hard, right? If I try to make one that's 20 sides, let's turn this a little bit here so you can see me. All right. If I try to do 20 sides, it'd be like, really hard trying to make it 20 sides, right? So it'd be really, really, really difficult, and we're not going to do that. So, limits. This gets to our idea of limits, right? You don't need to pause the video just yet. So, limits. Our first shape, it's kind of hard to see, but it was a triangle. Next, it was a square, and then a pentagon, which you can't see, and then 8 sides, and then I want you to think about. So, an n-gon is a polygon with n sides where n can be any integer. What shape, don't worry about that, there's a lot of mumbo jumbo there. What shape does an n-gon get closer and closer to as the n gets bigger and bigger? So, as my number of sides increases, so 3 sides, 4 sides, 5 sides, 6 sides, 20 sides, what shape is it getting closer and closer to? So take some time to think about that. What shape is it getting closer and closer to? Think about it. This right here, right? What shape is it getting closer and closer to? If you said circle, yes, you're correct. It is getting closer and closer to a circle, right? If I were to get 20 sides or 100 sides, it'd be really, really close to the circle. But will it ever be that shape? Will it ever be a circle? No. It would never be a circle. Even if it did 1,000,000 sides, it would never be a circle. So the way we would write that and say that in math is we would say the limit of an n-gon as n approaches infinity is a circle. Meaning, see that big old circle? The more and more sides we get, as n, the number of sides gets larger and larger, as it approaches infinity, it is a circle. Okay? All right, so that's what a limit means. All right? As it gets really, really large, what is happening? Okay. So, how could we write n behaviors as limits? Okay, this is where our math really gets into here. So take a look at this graph. Oh man, it's not that nice of a graph, huh? If I can zoom in here, really get in there. Is that better? A little hard to see. All right, we'll try it out. Oh man, that's really hard to see. That makes me mad. Okay, I'm going to pause this video and clip it with another one. Hey, welcome back. This should be better. As you can see, it's a lot nicer and easier to read. Okay, so the way I would read this, and I want you guys to say it out loud, write it down. The limit as x approaches -4. I'm going to write that. I wonder if I can write. I'll write it right here for right now. The limit as x approaches -4. That's what that is saying right there. The limit as x approaches -4. And we're going to see from the left. So, again, this is as x is approaching -4. You're thinking about what is the y value as x is approaching -4. So, follow your graph, right? Follow your graph. You want to figure out from the left. If you're saying from the left, this side is your left side, right? Left to right. So, from the left, follow your graph. Where is your graph going? As the limit as x approaches -4 from the left, right? We're saying from the left. It's going down. When it's going down and it doesn't look like it's going to stop, what is that going to be? If it's going down, and it looks like it's never going to stop, it's going to continue to go down. -infinity. So, as x approaches -4 from the left, it is -infinity. These are great notes to start taking right now. Now, as the limit as x approaches -4 from the right, okay? So you got to find, okay, here's -4. This is the line that is closest to that -4. So you're going to write it, and then you're going to see, oh, it goes up and up and up. It never is going to stop. What does that mean? The limit as x approaches -4 from the right is positive infinity because it's going up. So -4 from the right. You're going from the right, not to the right. From the right, it's going up. Okay. Wrong computer. So the fancy way that people write it. So these are some notes you want to take. The fancy way is the limit. I wonder if you can see this. The limit as x approaches a plus. See that plus right there? That means from the right. Means compute the limit of f of x as x approaches a from the right. The limit as x approaches a, and you see that little minus sign, right? That means compute the limit of f of x as x approaches a from the left. So, if you're thinking about like your symbols, this is the symbol that you should be thinking about. This is the way you would say it. So, again, x approaches a from the right, x approaches a from the left. Make sure if you need time to pause it right now to get that down into your notes. Pause it so you can look at it. I'm moving on. Okay. We did that. Okay. So, if I were to now write that notation, I want you to think about what this says. Limit. What does this say right here again? We have this right here. The minus sign means that x approaches a from the left. So the limit as x approaches -4 from the left, again, -4 is right here, the x. From the left is -infinity. -4 from the right, positive infinity, because it's going up. Okay. Okay, now another example here. I want you to pause the video right now and think about, how do you say this? How do you say this? And what is the value on this graph? Take some time, think about it. Pause. Alrighty, let's see what you guys said. So, if I were to read this out loud, the limit as x approaches 1, that minus sign means what? From the left. Yes, yes, yes. X approaches 1 from the left. So, I find 1, which is right here, and I'm coming from the left. So that is from this side. So 1's right here, so I'm coming from that side, and I'm following my graph, and it's going down, 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 to... Nope, I said talk to your partner. Yeah, talk to your partner on your reasoning for your answers. Make sure you do that. I missed that part. Whoops. We already did that. Okay, so... Oh, there is a typo in this. Oh, man, I made a mistake, but that's okay. So limit as x approaches 1 from the left. Where's it going? If you're saying negative infinity, you are correct. This slide is not. It should say negative infinity. Now, if I want to do limit as x approaches 1 from the right, so this is 1, I'm coming from the right, and it's going up and up and up. That's going towards, yes, you said it, positive infinity. Okay? And again, you are correct, that is not correct. So this is positive infinity as 1 from the right. Cool. Pause the video if you need to take notes. Here we are, moving on. Okay. Let's take a look at this graph here. It is a funky looking graph, and we're going to talk about what these funky looking graphs, piecewise graphs, mean in a little bit. Okay, take some private reasoning time right now. What does this say? What does this say? And what would the values be? Think about on this graph right here. The limit as x approaches -2, the plus sign means what? From the right, yes. Limit as x approaches -2 from the right. So, again, that's x is -2. So that is the value, the point you're looking for. So follow your line. Oh, wait. From the right, my bad. So from this side. So, once it, what is the y value? It's different this time, right? It's not infinity or negative infinity. It stops here. What is that y value? That's 1, 2, 3. And as x approaches -2, from the left is also at 3. So the value for both of those are 3. Because again, from the right, it meets at this point. From the left, it's at that point as well. And that value is 1, 2, 3. Take some time to think about that. Again, pause it when you need. So, does the limit exist? The definition of when a limit exists, and I want you to write this down into your notebook. We say that the limit exists at x equals c. It exists if this is equal to this. What does this say? Well, this is saying the limit as x approaches c from the left of f of x is the same thing, equal to the limit as x approaches c from the right. Whatever that value is the limit as x approaches c. As you notice, this one doesn't have a plus or minus. So, what that means is, I should copy that definition down, right? So this side, because it is from the left, is your left hand limit. When that is equal to your right hand limit, it's equal to the, this right here and this right here, the overall limit. So the limit only exists when your left-hand limit and your right-hand limit are equal to each other. If they're equal to each other, then the limit exists. But if not, the limit does not. Okay, so get that down into your notebook. Again, think about what that means. The left-hand limit has to be equal to the right-hand limit in order for the overall limit to exist. Okay. We talked about that. This is what I was just pointing at. So this is the left-hand limit. This one, you guys probably already wrote it down, is your right-hand limit. This is the value of your limit. So on the last one, it would be 3. And then this number, this value right here is your overall limit. Okay? So left-hand limit has to equal the right-hand limit. This is the value at where it meets, and that is equal to your overall limit, not left or not right. See? So when the left-hand limit equals the right-hand limit, the limit exists. Why don't we see some practice on see if the limit exists or not? Okay, take a look here. Does the limit exist? Let's see. Okay, I want to figure out, does the limit exist at x equals 2? Does this limit, the limit as x approaches 2, does it exist? Does it exist? In order for that to happen, the left hand and the right hand limit have to be the same. So let's find that out. Let's calculate the right hand limit. The right hand limit as x approaches, so the limit as x approaches 2 from the right, follow your graph from the right, the limit at 2 is 4. Right? So the limit there is 4. Sorry. Don't worry about these technical difficulties. That is so weird. Okay. Just take a little bit of time to think about what you have on your notes so far. You can fast forward if you want, because then this will be all fixed. Okay. Okay, there we go. So limit as x approaches 2 from the right, it is 4. Limit as x approaches 2 from the left, also 4. What does that mean? That means the overall limit, right? If the limit as x approaches 2 from the right and x approaches 2 from the left are both 4, the overall limit exists. So we know that right there equals to 4 is equal to the left-hand limit. So the right-hand limit is equal to the left-hand limit. Therefore, the limit exists. We would write, with no plus or minus here, the limit as x approaches 2 is equal to 4. Because that is where it is. That is where it approaches from both sides. Okay, pause and take notes if you need. We have just a little bit more, y'all. Does the limit exist? I want you to figure out if the limit as x approaches 1 exists. So take a little bit of time here real quick. Does the limit as x approaches 1 exist? Yes or no? Think about it, right? In order for it to exist, what has to happen? The left-hand limit and the right-hand limit must be equal to each other. So we got to figure out both sides of those limits, the left hand and the right hand. So It doesn't matter if you figure out left or right first. We can figure out left. So left hand limit as x approaches 1. I'm going on my left side here. So that is this line as x approaches 1 from the left. Where's my marker here? It fell. The limit as x approaches 1. Oops. Sorry. The limit as x approaches 1 from the left is equal to 4. Now, if we follow this, the limit as x, I keep doing that, I don't know why, as x approaches 1 from the right is equal to -2. So, does the limit as x approaches 1 exist or not? No, it doesn't exist. It doesn't exist because the left-hand limit and the right-hand limit are not equal. And so, therefore, the limit as x approaches 1 does not exist. Does not exist, or DNE. DNE does not exist. Doesn't exist. Not there. I don't know if you guys ever watched Mean Girls. If you have, you know this reference. If you haven't, you can look up this reference for Mean Girls. The limit does not exist. The limit does not exist. The limit does not exist. It's from Mean Girls, so if you know, I don't know if you ever watched Mean Girls, it's from there. Cool. So that is all our lesson for today. At your tables, you're going to work with your team to determine the left-hand limit and the right-hand limit for each of the questions at your table. Stick together and make sure you use the notation in your notebook. Okay? So this is your practice. Your exit task is this right here. So by the end of today, you should be able to calculate what is the left-hand limit of and interpret it as limit as x approaches 1 and limit as x approaches 3. What are those values? If you have any questions, watch this video again. Look up other videos on limits graphically. You can literally Google search limits graphically. And then they can help you out with that. All right. Thank you for your time. I know it's kind of weird, but I really do hope it helped out. The answer key should be on the board right here. It will be right here, your answer key. Also, if anybody wants, I'll turn the lights on there now. You know it's March Madness, right? So you can take one of these brackets, on the board, fill it out. If your bracket is the best, you earn lunch on me. It's a little fun game, okay? Alrighty. Thank you. Work hard, y'all.